Russia is one of the few nuclear powers on the Earth, and the ex-Soviet nation never fails to remind the whole world of its unique capabilities. However, the massive country is deploying its nuclear know-how in a new way that is causing other nations and scientists to be really concerned and fearful in space travel. Its announcement of a new nuclear rocket has shocked the entire space industry, as space is one of the few places where nuclear power has been tightly regulated. What is Russia's new nuclear rocket all about? When will it launch, and what missions and uses has Russia planned for its new rocket? In this video, we bring you all you need to know about Russia's controversial new nuclear rocket that shocks the entire space industry. Most people do not want a nuclear reactor in their backyard. This is why there are usually protests by the locals anywhere a nuclear plant is to be located. This is not surprising given the amount of potential damage a damaged nuclear plant can do. As such, nuclear energy planners continue to grapple with the bad rep their source of energy has accrued. However, how about a nuclear reactor in a rocket that is far away in space, hundreds of thousands of miles away? Russia thinks that this is a good idea and is actively working on a solar system exploring rocket that is powered by nuclear energy. The country's space agency, Roscosmos, has revealed details about the new nuclear-powered spacecraft named Zeus. It has also included information on the missions the new powerful spacecraft will go to. While nuclear power is a turn-off for many people, there are actually many advantages to a nuclear-powered spacecraft, which is why Russia is deeply interested in it. A nuclear reactor on board a spacecraft can generate specific power several orders of magnitude higher than other systems. This will allow Russia to reduce trip times. For example, a round trip to Mars using a conventional rocket could take 3 years in the best-case scenario. However, Russia has discovered it could cut the time taken down to 2 years with a nuclear rocket. That is a massive saving, as each day spent in space means an awful lot of money. A faster travel time in space also means the cosmonauts are exposed to less radiation. Deep space is full of cosmic radiation, and the best idea is to spend the least time out there. Russia reckons it can get ahead in the space race cheaply using rockets powered by nuclear reactors. Another benefit for Russia is that nuclear energy can allow its rockets to increase their payload capacity. This means transporting exploration equipment can be cheaper, and simply more stuff can be moved to space for different missions. Russia is one of the countries racing to return astronauts to the moon and even set up a permanent presence there. This requires a lot of supporting infrastructure to be moved to the satellite in advance of the astronauts or cosmonauts. Russia has also threatened to pull out of the International Space Station and build its own, which it will single-handedly operate. Its upcoming nuclear-powered Zeus rocket is a cheap method of transporting all the modules required to set it up. But that is not all the benefits of a nuclear reactor powering a spacecraft. Nuclear reactors could also be used to provide cosmonauts with a reliable source of surface power for extended exploration missions. Russia could also sustain human presence on other planetary bodies, supplying power for decades without the need for refueling. You may recall that one of the drawbacks of the new James Webb Space Telescope is the mission ends when the fuel on board runs out. However, a nuclear-powered spacecraft can last much longer. Russia has huge ambitions for its nuclear-powered Zeus spacecraft. The plans are sufficient enough to change the entire course of space exploration as other nations scramble to catch up. The country's news agency TASS has revealed Zeus's mission, which is uncrewed, will last 50 months. It will travel as far as Jupiter in a multi-planet trip. What is even more astonishing is the time frame for Project Zeus. The rocket will reach Jupiter by 2030. Coupled with the plans to launch its own space station and audacious attempt to land a probe on the southern pole of the moon, the rest of the years before the end of this decade is going to be a busy one for Russia, and Roscosmos is counting on the new powerful Zeus rocket. Zeus is going to be a beast powered by a 500-kilowatt nuclear reactor. The reactor will work just like any reactor built here on planet Earth. Altogether, Zeus will weigh up to 22 tons. Russia is now making calculations about Zeus's flight's ballistics and payload through the Russian Academy of Sciences. Zeus's first port of call is the Moon. When it arrives on the Moon, Zeus will release a spacecraft that will travel all the way to Venus. When it gets to Venus, the spacecraft will use the planet as a gravity assist to launch yet another spacecraft that will then journey to Jupiter. Russia will use the Zeus module as a mobile source of nuclear power for future spacecraft that may attempt to make even longer journeys through space. It has been developing this rocket since 2010, and the preliminary design is soon to be completed at the cost of 4.2 billion rubles. However, Russia has another use for Zeus that is giving other leading nations sleepless nights. The badass nuclear-powered rocket will be able to shoot down enemy spacecraft from orbit. The Keldysh Research Center showed that Russia will deploy Zeus in an anti-aircraft defense, where it will detect air targets from orbit and relay the information to anti-aircraft systems. The Arsenal Design Bureau has conducted a research project that reviewed options for using a spacecraft with a megawatt-class nuclear power propulsion system, which is no other than Zeus, to perform tasks including probing the Earth's surface in the near-Earth airspace from a distance, electromagnetic interference with electronic components of control, reconnaissance, communication, and navigation systems, directed energy laser emission, and more. The Keldysh Research Center also revealed plans to test a drip refrigerator emitter for the nuclear-powered tug on board the International Space Station, but that was before Russia indicated it wanted to build its own space station. Space exploration is a competitive business, so Russia will not reveal all the details about how Zeus's nuclear reactor works. However, one of the options Russia could take with its nuclear reactor is NTP, or nuclear thermal propulsion. NTP works by pumping a liquid propellant, most likely hydrogen, through a reactor core. Uranium atoms split apart inside the core and release heat through fission. This physical process heats up the propellant and converts it to a gas, which is expanded through a nozzle to produce thrust. Zeus as an NTP rocket will be more energy-dense than chemical rockets and twice as efficient. This performance is measured as specific impulse, which is the amount of thrust you can get from a specific amount of propellant. The specific impulse of a typical chemical rocket that burns liquid hydrogen and liquid oxygen is 450 seconds, but that is only half of the propellant efficiency of the initial target for nuclear-powered rockets. This is due to lighter gases like hydrogen being easier to accelerate. When chemical rockets are burned, you get water vapor, a much heavier byproduct than hydrogen that is used in an NTP system. This leads to greater efficiency and allows the rocket to travel farther on less fuel. But can Zeus pose a nuclear danger when it is finished? Many people would like to know this. However, the truth is that NTP systems don't have to be used at launch. Zeus may be launched to space using chemical rockets before its NTP system is turned on. As a result, the ground crew and other humans nearby are protected from fatal radiation in case of an accident. In addition, NTP systems are designed to use low-enriched uranium. This will help to avoid the high costs involved in keeping highly enriched uranium fuel safe or away from harming humans. Roscosmos is in a role with nuclear-powered rockets as it has signed a contract with the Design Bureau Arsenal to develop another nuclear-powered space tug. This one is called Nuclon. Russia will take the delivery of the design in July 2024 at a cost of $57.7 million. Meanwhile, the US is not sitting idly by and watching Russia race past it on the power of nuclear rockets. It has also been testing nuclear rockets as a means of propulsion in deep space. Back in 2012, a NASA team of researchers from the Glenn Research Center in Cleveland and Los Alamos National Laboratory in Los Alamos showcased a novel concept for a reliable nuclear reactor that could be employed in space flights. The team displayed how to use a heat pipe to cool a small nuclear reactor. It was also the first to use what is called the Stirling engine to convert the reactor heat into electricity. The test was conducted at the Nevada National Security Site's device assembly facility near Las Vegas. NASA's heat pipe is a sealed tube containing an internal fluid that efficiently transfers heat produced by a reactor. It has the advantage of using no moving parts. Heat pipe technology was invented in Los Alamos in the 60s and is used widely by NASA for aerospace applications. A Stirling engine is a closed-loop engine that converts heat energy into electrical power using a pressurized gas to move a piston within a magnetic field. The research team combined the two concepts to create a reliable electric power supply that could be imported into space applications. Let's hear you in the comments section if you think Russia can win the space race with its new nuclear-powered rocket.